I have a quick question.
Mm-hmm.
So for the interactive, if you're going to submit job in interactive queue,
Okay.
is it the only thing that I'm going to change is just queue instead of short or long? I'm just going to put interactive. Is that all?
Yeah, so interactive is the queue name. So
Mm-hmm.
you cannot use both long and interactive. So interactive queue is always short and the name is interactive. So you're not going to use the name short. You're just going to use W120. You can also set the memory here too, like you said the other one. But you're not going to use for this dash Q, you're not going to use short or long. You're just going to use interactive and then it's going to start.
So even if I don't know how long it's going to take, so is the computer or is it the cluster that's going to determine, the hours? Um, oh, okay, never mind, never mind.
Yeah, this is 2 hours. If your question is like, this interactive queue will be killed in 2 hours. Even you don't
Okay,
kill, it's going to be killed in 2 hours. But if you're not
okay,
using anymore, just exit.
okay.
And then it's not going to be there anymore. So let me check. Sorry, P jobs. See, I don't have any jobs now. And I can see B jobs minus A. With this command, you can see your B jobs minus A. See, I had 2 interactive jobs done and 1 job finished with 3, and then the other job was exit. So I killed
So
this.
do you always end it with ls bash?
Uh, this is not ls, this should be is. Where is it? This is is.
Do you
No,
always end it with ls bash?
but this is this is just a shell we are using in cluster. But if you specifically define your shell, there are other shells that they are slightly different. But today bash is enough for everything. So I never change it to other shells. Like other shells means like there's another shell called sh, for example. This is a shell, or zsh, another shell. But bash, even advanced users don't change this. We always use bash.
Thank you.
Okay, you're welcome.
So one more question. In this command, when you switch to interactive, where is the name of the job?
So the job name is not that important. It's job name is here bash, but it's not that important. This is interactive job. You're just using this. The meaning of interactive is you are using a node and you're copying files, or you're doing some operations here, or you're just testing your star command, for example, with the parameters. If the whole command is working, then you will start submitting the real jobs that I showed you. So like not interactive, like the jobs to the queues, like to the long or short queues. So here,
So, my question is, when you're telling the system which queue you plan to use, where is the information about what type of work you want to do?
what type of work is here. So in interactive job, you're not gonna tell anything. The work is gonna be bash in interactive job, because you will interactively run, for example, sleep 300 here. Okay, this is the job that you are interactively doing. Okay, like for example, wait 300 seconds. I'm doing this now. And when I enter, it's gonna wait for me 300 seconds. I'm just gonna stop it. But when I want to submit this job in the backend, means like, for example, short, I'm going to submit this to the short, and the job now is going to be here, like the job, whatever I want to run. Like, for example, I want to run star, or I want to run ls minus l. This is just a command, and then put the ls results into ls results.txt. For example, like this. See, this is going to, the things inside of the code will be submitted to the cluster. This can be a huge command that you're going to learn next week. Like you're going to learn how to submit star, or how to submit RSAM jobs, or how to build an index file. So you don't do these things on the head node. Sometimes you don't do these things in the interactive node too. What you do is you submit them to the short queue if it is short. If it is long, you submit them to the long queue. So when you do this, see, it's submitted now. So this job is finished real fast. Let me show you. It's still running. Let me see. It's done now. See, it's very fast. I'm going to show you. So it is done. Just to see the results. So you can just go here. See, ls results. See, this is it just ran ls command and put the results into this file. So this command here is doing that, like, ls minus l, this is gonna go in to this specific file. So in the future, when you submit a command like this, you can always put the result of that, like standard output of that command into a file, just to check everything is finished like you were expected. So this is important. Otherwise, it's gonna write the standard output somewhere else that I can show you those things too. But you have to go and find that specific file to see if the output is right. So because
I'm sorry, maybe I did not ask the right question. So in the comment that you wrote before, what is bash mean?
Bash means, like in the first class we talked about it, bash is the shell. Means
no, I understand. You wrote for interactive queue, this comment was is bash. What does it mean, is bash? What do we actually do? What do we ask computer to do?
To give me a shell. You're saying that you give me an interactive bash shell, and then you can do things interactively. So this is what it is doing. Okay, so this is just a bash is also a command. See, I can also do this bash here. See, bash. So I get this one, but I'm still on the head node. See, I am still on the head node, but I get the bash. So what it is doing, it's just giving the node and running bash command there, and then giving me here, and then I can use this interactively. Okay, this is it's giving me the shell. Okay, so let's talk about some useful commands that are going to be important for you when you are running any commands in the cluster. For example, sleep 300. When you do this, sleep 300, it is going to wait 300 seconds. Okay, so but sometimes when you're running these things, like I just exit now with Control-C, but in the interactive node, I want to do a couple of more things, not only sleep 300, because sleep 300 is not going to even use any, I'm going to go to interactive node now. I don't want to use the head node, like you should do the same thing. Where's my head node? Okay. Okay, so I'm going to go to the interactive node. So when I'm using the interactive node, I'm just going to run this, but when I run this, see, I cannot do anything else. I have to either open another interactive node, but I know this is not using any memory, usually copying files or doing these kind of operations are not using memory or CPU. So you can use the same terminal with many multiple operations. So for example, when I run this, but it doesn't give me the command, this command line back. It doesn't give me that. So what you can do, you can use Control-Z. Okay, I just stopped this with this Control+Z. Okay, this is very helpful, and this only stopped. It is still running, by the way. When I do this PS command, my sleep command, it is not running now, but stopped. It's like suspended. You can think like this. This is the PID is the process ID, and it's just sleeping. Sleep is just waiting now. This could be multi command, or this could be a copy command. This could be FTP command, rsync command, but you just send them to the background. But it's not running now. But how I can send this to the background, but it is still running. So how you can do this, after you use Control-Z, you can just use BG command. This means it's in the background now. This is running 300 seconds, and the clock is ticking now. Like in 300 seconds, it's gonna be done. And while you're running this, you can send this to the background like this, any command, okay? This is just an example, sleep command, but you could run any other command, which is waiting like this more than a minute or something. If you don't want to wait, if you want to do other things while it is running, you can do that. How you can see if it is still running? You can always use this PS command. PS means it's just printing all the running processes. See, this is bash that I run to get this bash, and sleep is running now, and then PS command running, and this is another interactive job is running in the interactive node. You don't see it if you do this in your own laptop, for example. But when this is running in the background, if you want to get it the foreground, you just write it FG. See, sleep 300. It came to the foreground and waiting again. So it doesn't give you the line to do operations. I can send it back again and then BG. So you're just interrupting the command, and then, but you have to write this BG to start running at the background. Okay, so another thing you could do, you can run the commands with the and symbol at the end like this, space and symbol. So this is gonna wait 300 seconds, but when I do this, it's gonna go immediately to the back. So this is the second process running in my bash. This was the first, this is the second. See, when I do BG, it's already in the background, but I want to get it to the foreground. See, I get this one to the foreground, FG2. But I'm going to send it to background again, stop. But it's both of them are 300. You don't see if it's the first one or second, but it's working like that. You can bring anything running at the background to the foreground with FG, and then send it, Control Z and BG. But at the beginning, you can use this AND while running to send the command immediately to the background. Yep. So by the way, these are not jobs, okay? So I cannot call these like commands jobs. Jobs, when we call jobs, the things we submit to the scheduler, they are called jobs. But these are, we are using interactive queue to run some commands. These are commands, okay? And I'm running these commands. And if you want to send multiple commands to the background, like, you know, sleep, I don't know if this is going to answer your question, but for example, sleep 1000 will send one command to the background, another one, sleep, like for example, 500. And see, these are in the background now. I have like 4 jobs, 1, 2, 3, and 4. PS, there will be 4 sleep jobs waiting there, and they are just sleeping now, but they're also running. So they haven't stopped yet. If you want to stop them for a reason or kill them, you can kill like this, kill -9, this job. For example, this is the PID, but this is different than job ID when you use B jobs. Okay, this is running interactively on the node. And if you want to kill the process, you just write it here, and then it's gonna kill, see? No such process, because this is just finished now, done. I couldn't kill, but I can kill the second one, this one, because this was like 1000 seconds. I can just kill that one. See, PS, I have only 2 now. This job is killed. Number 2 was killed. So you can always run things. If you're not happy with that run, you can kill it. But again, these are not jobs running. If you submit the jobs, like in the previous session, if you submit the jobs, it's different. They're running there. If you want to kill them, you're going to kill the whole job using B jobs, get the job ID, and then use B kill and the job ID to kill the job. But this is, you're running a command, not using LSF, but itself in an interactive job. Like you can do these things inside of the head node too, or in your Mac machine in the terminal too. Like for example, you start a copy operation and then you realize that one file was missing, and then you put that file and then kill the copy job and then start it again. So that's why sometimes you don't want to wait till they finished. that you can kill them, kill the jobs. But I want you to understand what the process is and what the job is. So process, again, process is the commands running in the interactive node that you run yourself like this in the shell, or in the head node, or in the child node. But the jobs that you learn in the previous session, that you submit exactly the same job, but you submit to the LSF, and then those are going to be your jobs. So I want you to separate those two things. The reason that we submit the jobs was, one of the reason was that you are submitting them and then they take a lot of time. That's why you submit them and then they go there and then run. You can submit many parallel jobs like this and then you forget them. But here, when you run this, then you are running this in the interactive node like this. When the interactive node is killed, they're gone too. They're going to be killed too. So that's why you don't want to run the processes like this interactive job unless they're going to finish like in 300 seconds or 500 seconds. But if they take time, you want to submit them to the cluster as a job. This is the only difference. So you can use another one, another PS minus F. Oops, PS minus F to see who submitted the job and what is the job name. See, sleep 1000, sleep 500. It's like it's not only sleep like the short format, but longer. You can see the whole job, whatever you started running. So how you get out when the you can either use the exit, or when you are here, when you started running, for example, a command and takes time. If it takes time, you either kill it with Control C, or with Control Z, you send them to the background, you stop them, sorry, and then use background to send them to the background. So when I do this PS minus F, see, I see the last job that I submitted now here is here now. See, it wasn't there before. And the job process ID is here. If I want to kill the specific job, I'm going to use kill -9, this number. So these are the things that you have to get familiarized with, because you're going to do this lots of copy operations or FTP operations. Sometimes you want to kill them. And you need to also learn, again, you can visit the previous, like last week's session, to change the file permissions, directory permissions, when you're sharing these files with other people. Okay, so this is these are some explanations about what the columns are. You can read them. You'll learn how to kill. By the way, if you don't use 9, it's gonna terminate again, but -9 is forcing to kill. So usually I use like this, but sometimes this can be dangerous to kill like this to the file system. But you know, I usually force, I don't want to wait sometimes. And you should do like this. Start killing like this. If it doesn't die, then you can kill like this. There's another command that we use a lot, top. Sometimes, you know, I am trying to use this specific server here, but when I even do ls, it's not doing anything. And I'm trying to understand the reason why it's not working. Most likely the reason is somebody in the same node is using excessive memory or CPU. Just to understand who that person is, you can use top. See, nobody is using this. I am the only person using, and I can tell I'm using only 1% of the CPU on this machine. There's another person now on the same machine and gone. So one person run, so you can see that person. And see, this is, I'm running now, top command. But sometimes, you know, the people like our admins, cluster admins, sometimes they just get in here and then see the operations, they check if somebody is doing something wrong, they kill their jobs. Especially in the head node, they're always checking the head node. So if you do excessive job runs or process runs on the head node, they kill your jobs. If somebody's killed your job, the reason is they did. So the reason is you're doing something wrong, most likely. Another thing is, 1 second, the top command, you learned that, and also the pipe. This is very also useful command. You can run multiple commands at the same time. So it means the output of this command is gonna be the input of this command, means this. So for example, ls minus l command is gonna do this. And by the way, to exit this top, you can use Q or Control C. Q or Control C in your keyboard. So another thing here, ls minus l is this. So just to count how many files or directories I have in this folder, you can just do this, ls minus l, vc minus l. So this is going to give me the number of lines in this command. But this command could be anything. So you can, like, for example, I can see cat, like, for example, class. Cat was going to write the number of all this code inside of funcs.r file. And I want to see how many lines I have in this file. You can do this. See 176 lines in this file. So you can actually use this pipe operation to send the output of this to this file. I'm going to show you grep at the end of today. So grep is, for example, I want to grep this line, something that includes genome point inside, for example. I'm going to do like this, funcs.r grep, grep, for example, genome point. How many, see, I have one genome point here, one genome point here. There are 2 genome points in this file. So you can just grab some lines that you are interested in with some keywords you want to use. For example, PCX. I just want to get the PCX in this file. Grep PCX. See, there are multiple lines here with PCX, 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 and PCX. And I'm going to show that later. But sleep 300 is done. See, it was running at the background, number 5, and it's done now. And then you can see when they are done. When you copy a file, you're going to see done, CP operation is finished, for example. So these are things you run at the background. So you learn this cat. And for example, if you want to quantify the number of lines in a FASTQ file, but these can take a lot of time, by the way. That's why sometimes I send them to the background. But these files are small here. These are example files. So you can do like this, control replica 1 FASTQ, and VC minus L. See, these are these many number of lines, but you're going to see next week that these reads in these files are like in 4 lines. So the first line was the name, the second line was the read itself, there's plus, and the quality line. So every 4 line has 1 read in it. So that's why when you do this kind of thing, cat control replica 1 FQ, this is going to give total number of lines in this whole file. And then you have to divide this number to the 4 to understand how many reads you have in this file. And yes, now the grep command that I showed you how you're using this grep. For example, this is a good example that you want to use. See, these are April 7. I created these files on April 7. So, but let me see if there are other, these are all April. CD, maybe MM10 is not. Okay, perfect. See, there is one May here. So you can just grep, you can do ls minus L. Grep May will bring you the files created on May. See, there's only one file created on May. So you can do these kind of things with grep command. And what else you can do? For example, you want to bring the lines that doesn't include May in it. You can use -v. See, May is not there anymore. Only April's came. Sometimes you want to do these. So why this is good? Because sometimes, for example, you have one read, just to show you like very good use case. I'm just gonna go back. Just gonna go reads. For example, FQ. So, oh, sorry. Control rep 1 FQ. So for example, I have this kind of sequence here, and I want to grab this sequence in my FASTQ files. Control or this specific file, this file. See, you can do this grab. See, I have this specific sequence exists this many sequences. So I can actually quantify. If you have a specific motif, for example, or specific sequence, you can quantify like this just to check if your data is right or not. We do these kind of things a lot. So, or you just want to see where they are. So there is also a very cool option here. You can use color, -- color equal always. See, you can see where this specific sequence is. So it's I really like these kind of things, just to see if I'm doing things right or not. So especially when you have a 3' barcode or 5' barcode in your sequences, just to check where they are, if they exist, or what the barcode is, if your sequences are right. Even you use sometimes barcode, you cannot find a barcode in it, 3' barcode, for example, to remove them when you're doing small RNA-seq, and then you realize that your barcode was wrong. And then you have to find the right barcode and then use the right barcode to remove that if you're working on small RNA-seq, for example. And yeah, you learn this color thing, and you can, if there are many lines, you can use more. If you have, like, for example, if you reduce this, many lines will come. See, many lines came, and you can do more. And then see page by page where that specific sequence is in your file. And you can also do this too. See, you can always use this dot star, for example. Means this is the wild card. It's going to have this. There's something in between and TGA. And when you do this, see all the sequences, and you haven't defined how many nucleotides will be in between, but you can grab these things just to check. Sometimes, you know, you did barcode sec, for example, and you have the one variant that you want to check how many variants you have in your barcode sec analysis, just to do some checks, and then you can search that barcode, and then you can put this dot star. If there's a variant in some specific location, you can just write the 5' barcode and then 3' barcode, and then search if your sample's right. Or sometimes, you know, you give your samples to the people. This is happening to me a lot. And some people are coming to me and asking, hey, a bioinformatician analyzed my data, but they couldn't find anything. Could you please check if this is true or not? And I'm checking. Sometimes, you know, they forget something at the bio. So don't trust everybody, you know, don't trust me too. You have to check your own files yourself. So these are the ways how you check. There are some sanity checks like this. For example, sometimes your files can be really not right. You know, they maybe your experiments didn't work and you have nothing in your files. This is happening a lot too, but you have to also go and see yourself with your own eyes, because you're spending a lot of time to create these sequencing results. And then sometimes when you have nothing, they say you that you have nothing, but you have to at least show the people that, hey, I have this. Can you please tell me why? You know, at least you have to learn this much to tell the bioinformatician everything you did is right, or at least you're going to be convinced. If you don't have this, for example, barcode in your files, it means maybe you only have empty vectors in your sequencing, means you have nothing. There's nothing sequenced in your files. So at least you have to be sure that your experiments didn't work or they are worked. And then sometimes you need to convince people that it worked. And I experience these kind of things a lot. So if you want to grab one thing, remove them, and then use the rest to grab another thing. So you can do this using the pipe. See, these are going to be, this is going to remove the things that has these sequences with these sequences, and then you are going to grab something like this. See, this means GCT, and there will be any nucleotides, but the length of these three, the nucleotides will be 3. So that means anything. And when you use dot star, this means anything, any length. Okay, so 3 dots means there'll be 3 nucleotides, and you're going to see CG. Sometimes, you know, you just want to search them. See, these are exact length of motif, for example, that you are looking for, that you think it exists in your files. So when you show this, then you can, for example, this is a chip library, and you know that you want to show that this chip library worked, and you have a motif. You're just going to get one sequence from that motif, and in that motif you might see GCT in the first 3, and then CGC in the last 4, and then 3 you don't have like a strong motif nucleotides there, then you can put dot there and then search this and then see how many reads has this motif. So just to show that your chip worked, for example, this is a transcription factor binding site motif for a specific transcription factor. So you can actually use this kind of graph just to show that your chip experiment worked. Another thing. Okay, so grep worked, and then I want you to repeat these things yourself, by the way. I just told you what they are, but then for AUK, I'm going to give you the time how to run AUK for yourself. And then next week, we're going to talk about what SAM files are, what BAM files are, what FASTQ files are, or these kind of different formats. And you're going to learn these things better, what FASTQ files are. But we also talk about these things here, but I'm going to go over them. So now what I want you to do, so just don't focus on what this is now, for now, because this might be hard to learn what our command is. But what you can do, if you learn, like the name of the command is AUK, okay? And what you can do, for example, there are many things you can write here, and many AUK commands you can find on the internet. You can tell, like, you know, give me like second lines in every FASTQ file, for example. If you run this, our command, see, this is going to just give you, see, all the sequences in a FASTQ file, and then with less or more, same command. You can do more too. But see, these are only the sequences. It means this. So NR is the row number, and this is the mode symbol. So it's just dividing the row number to 4. If it is 2, means it's going to print all the line to the screen. So here, these are, we knew that, I told you before, that in this, let me Control C, maybe I can show you again more. In this file, there are 4 lines. In the second line, I have the read. And I only, for example, if I only need the read names for a reason, sometimes you need these kind of things, you can just change this to 1, because this is a mode symbol, dividing this number to 4. And if the result is 1, and then you can just get the read names. These are the read IDs or names. And, but we are going to talk about what they are here later. But again, if it's 2, you can see these. By the way, when you press up and down arrows in your keyboard, you can actually bring the commands you wrote before if you need a change, or if you make a mistake, you can always bring them into your screen and go back and then fix things. Okay, so this is the out command you're going to learn. It is going to help you a lot in the future just to modify your data to do some things, some operations. But what I want you to do, I want you to do all these things from the beginning yourself. From the beginning to here, just read and do it yourself. And last thing, maybe I can show you this too. This is an editor, VI. This is a kind of hard editor, but you can choose any other editor you like. But this is something very powerful that I like using. And that's why I want to show you. Some of you guys might like, some of you guys might hate, but if you like, there are many things that you will see. It's very powerful while you're searching anything in the file, while you are replacing file, and it's extremely fast. So sometimes even I open FASTQ files with this editor. You cannot open, don't try opening FASTQ files with any other editor. This is going to be slow with this too. Usually I don't do that, but sometimes if I really need to change something in the file, it's, you know, I calculate the size of the file and then I do these kind of things. But what I'm talking about, so this VI is an editor that you can actually create some files yourself. Very fast, I want to show, like for example, VI, my command. For example, I'm going to create a command here with VI editor. But when you enter here, you cannot write anything. This is a file. It's going to create this file. And for example, I want to write something in it. Like, for example, I want to put this grep command here. Like, for example, I'm just going to put this grep command, and I'll show you one thing that you will like. So to write anything here, you have to press I, just to get into the insert mode. So we wrote this into the material there, so you can learn it like this. But when it is insert mode, if you want to escape from insert mode, you have to press escape in your keyboard. Again, I press I and I paste this. Okay, so this is the command I wanted to run. Okay, so then to exit and save, you have to do like this, escape again. You're gonna see there's nothing written here on the bottom, at the bottom of the page. If it is an insert mode, you're gonna see the insert here that you can write. See, I can write and then I can delete. But if it is not in insert mode, if you press escape, it's not going to be an insert mode, then I can save and exit. So I'm gonna do that. To save and exit, it's written in the material there, but you can do the column, W, Q, and exclamation. So this will save, write, and quit. So it's gonna exit after saving. If you just Q, if you press just Q, it is going to just exit without saving. See, my command is here, and I'm just gonna cat the my command to show you. See, this is inside. See, when I want to run this command, I'll show you two things that I want you to learn here. One is when I try to run this, because I didn't give any executable rights, my command, it's in this directory, / is going to be, it's going to say that this is in this directory, my command, see, permission denied. This is not going to run this. But you ask me what bash is. Bash is something you can actually use this command to run other commands like this by without changing the permissions. See, it ran. This is what you were asking me, what bash is. Bash gives my command, this command, to give a shell to run, to execute a command in a file. So this is another way of using bash. Okay, you can always run like this. But if you don't want to run like that, what you can do, you can change the permissions. You can give the executable rights to this command. And now it is going to do the same thing without bash, because it's executable now. And it's doing this. But I will show you one more cool thing that you might like. So I just want to, I like this command, but I know that I will run this command a lot. but I don't want to like enter here, change the file name and run one by one again. What you can do is this. You can just delete this with X. I'm just pressing X now when I'm here. X means like it's deleting, or you can go into insert mode and use backspace or delete to delete anything here. So I'm in insert mode now. So what I'm going to do now is I will put this $1 here. This means that it will bring a parameter from outside of my program. So when you're writing scripts, you're writing some stuff like this. This is a variable. It's called variable. $1 means, I'm sorry, I'm just going to escape and show what it is. See, this was my command. And after, if I want to send one variable, like one file name to this is going to be used inside of $1 variable. Okay. So this is a very cool thing. I just wrote a script like this. And then when I change the file, see, this is for the first file, and I will just count, for example, how many of my sequences in my first file has this motif, for example, or the sequence, that the sequence was here inside of this command. And when I do like this, for example, if I want to change the file name to control replica 2, see, 26. It used the second file. See, this is not $1. So, for example, if I want to change this sequence, also I want to enter this sequence from outside of my command, you can go and it doesn't need to be in an order, but you can change this to $2, for example. I'm just gonna get that information again from outside of my script. See, it was like this before, and I'm gonna get this as my command. This is the first parameter, and the second parameter will be the sequence. See, it came. If I want to change the sequence to something else, for example, see, I changed it and those things came. So you can actually create your scripts yourself by using these commands that you're learning today and put them into a file using VI, learn VI, and then put them into a file like this. For example, you can put this bjobs, grep job, you can use pipes, and then this $1 is in awk, and this is going to put the output to here, and it's going to use the first column here as a parameter inside of awk, for example, and then it's going to print the first column. So if you learn these things, your life will be much easier. That's why we are showing these things. But there are lots of details about these things. Like, if you search, there's a tutorial for VI. If you go here, you can learn. There's a VI text editor. There are lots of things you can do with VI. You can actually go here. You can delete the content. You can do undo. It's like a Word. It's better than Word. Word editor, like Microsoft Word. It's better than that. But you can do many things here. So just you can search your own tutorials. You can search your own cheat sheets. For example, if you search VI cheat sheet, like VI cheat sheet, to understand what kind of commands you have, and then print this and put this cheat sheet into your somewhere, and see, these are all commands. See, for example, U, like small u in your keyboard will do undo, or like capital U, if you use Shift U, it's gonna do undo all commands. Or if you want to copy one line and then paste somewhere else, you just press YY together like this. For example, I'm gonna show you very cool things you can do. That's why in the future, but for example, I'm gonna do YY now, and then P will print the same line here, and then you can change it. So you can do things much faster if you learn these things. for some of you guys will love it. Again, I told you, some of you guys will hate it, but it makes our lives much easier if you use like these things like grep, vi, awk. Your life will be really easy when you want to run like multiple things by changing these things. And you're going to learn pipe to run multiple commands. And I will talk about them more. So now I will give you more time, maybe 20 more minutes, and 11:55 I'll come back to tell you bye. But you can actually finish all this and do your station homework here, and then I will answer a couple of your questions, and we will continue next week. Any questions now? I can't hear you. I don't know why. Yeah, some people says we can hear you, but you cannot hear. But it was a long time ago. Okay. Yes, VI is the Vim editor. They are similar, exactly the same actually. The name was VI before. They add more functionalities to VI. It became Vim. So, but you know, when you can use Vim too, and it adds some color, like Vim, my command. It's not installed here. But in Ubuntu or any other Linux distributions, it's installed. I'm not sure if there is, it's installed as a module. I'm not sure. It's not, I think. It's not installed here, but if you have, maybe on my Mac, I'm going to check my Mac. Yeah, on my Mac, it's installed. See, this is Vim is VI improved. So you can use that too. In other Linux machines, it's also installed. So, but here, I didn't know that it's not. But VI is very similar. You know, there are not many differences that you're going to see. Any other questions? I hear a sound. Raise the hand. Yeah, Sam, please ask your question.
I think that was old. Sorry.
Okay, sorry. Okay, any questions, please, if you have any. Okay, is there a difference between using dot and dot star? Yes, the difference is this. If you just use the dots, for example, I'm going to change my command like this. I'm just going to get the whole thing from outside. Okay, and just to show you, like, for example, dot.
Alper,
Yep.
you didn't share the screen.
Sorry. I always forget that. Share. Thank you. So what I did was I just removed this thing, like all this thing. I just put the whatever I'm going to grab into $2, and I put color, and $1 will be the file name that I want to grab. And when I'm running, so I'm going to put this is number 1, control rep 2, and I'll put just dot here and TCGA, for example, TCGA. See, dot correspond to 1 nucleotide here. See, these are CAGC, AGCA, and there's just C here, and TGA. But if you want to do many, like multiple, oops, here, see, there can be more than 1 nucleotide. If you want like 2 nucleotides, 3, 5, you can just do like this too. But there's nothing such this, for example. 3, yes, I have 1. So you can write these kind of commands to yourself and then run them when you need. Just simplify your job. Any other things? Star and dot star. Yeah, if you use the star there, so it just requires the previous character many times. See, in this case, only A, the shorter ones came, only A came. They're not long. But sometimes, you know, you just want to search poly A, for example, like at the end, you can just search like this. There's just one A at the end. But if there are two A's, they would be here. Or something like that. Or if there is no A, they're going to come too. These are going to come too. Star means 0 A or many A's. The star means that. Question mark is this is going to be 1. This has to be, or no, I don't know. Question mark, maybe it's not working in grep, sorry. But question, if you learn Perl in the future, they have a similar wildcard characters. They also use question mark. I don't remember. Let me check. If, by the way, if you are curious about it, like grep, wildcards. There are many other wildcards for grep, so you can learn them in here, like how it is working. For example, space usage, star, if there's space in between in the future, if you need space, or other things you can learn. Okay, any other question? Okay. Good. Then I'll give you 15 minutes. Then you can do things here. If you have questions, I'll answer at the end.